Hello, this is Daniele, and today I will show you my CDK setup to enable a serverless solution development locally. And I will show you mainly three things: how to extend the capability of your code to the usage of Lambda layers. I will show you how to invoke your Lambda locally through the browser or passing a custom input event parameter. And lastly, I will show you how to let co-live TypeScript function within a CDK Python project. So I created also a repository for storing all the configuration I will now show you. So you can find it at this URL. I will put it also in the description of this video. So once you clone the project locally, I already did it, you can open it with your code editor. I will use now Visual Studio Code, and you will find also additional information in the README file on how to get started. So every time that you have a Python project, I suggest to create a virtual env to install the dependency, like described here. We will use python.env module to do so, and we will then activate. You can see here the environment is activated. We can install the dependencies. Okay, done. Okay, this is a Python CDK project, a standard one. I just created a function folder in which I'm storing the Python source code of my Python function and the TypeScript code for the TypeScript function. I created some additional script to simplify what I wanted to show you. So in particular, the building of the Lambda layers and the start of the local test server. I configured a custom stack to include a Python Lambda function and a TypeScript Lambda function. So let's start with the first tutorial, how to extend your function capability, including external libraries through the usage of what AWS called Lambda layer. So in this case, you can define all the resources that you need here. I'm starting with the definition of the Lambda runtime version. In this case, it's Python 3.8. I also created a Lambda layer to the usage of the Lambda version construct in CDK. I have to specify a local folder from which the additional libraries will be loaded inside my Lambda layers, and I have to specify what are the runtimes compatible with this Lambda layer. And in this case, of course, the Lambda runtime we will reuse also in the Lambda definition here, in which we will have to specify, also in this case, where is the source folder of my Lambda function, what's going to be the entry of my code. In this case, lambda.py is the name of the function that I'm invoking, and also what is the Python function to be invoked whenever the Lambda is called. I have to specify, of course, most importantly, the Lambda layer to be included in this Lambda definition. So having a look at the code, this is a standard Python project in which requirement.txt is the list of the dependencies, and include my numpy function here. And I will use now a script to put this here to show you how to test and to build actually your Lambda layer function and create the local folder referenced in the CDK file. So basically the trick is to run a Docker container with a mapped local volume with a local folder, and install in that through the Docker container the requirement.txt dependencies. Sounds very complex, but in the end it's just a Docker run with a volume mapped locally, as I said. You have to pay attention that the Docker version is matching the runtime that you will use in the Lambda function, and then run the container pip install, specifying the requirement.txt file selecting as target the local folder that you are mapping in the volume. I created a convenient script parametric, so you can change it. You don't have to remember this. So to run it, script build run layer. Okay, the installation completed successfully. As you can see, a new folder now appear in the file system. This is the folder that we are referencing in the CDK definition. Okay, so now we added NumPy to our runtime of the Lambda. Let's try to use it. Simply import NumPy. And let's try a very simple use of, let's try to return the version wherever we invoke this Lambda. Okay, so now we want to try to test this Lambda. And to do this, since we don't have to pass any input event, we will create a local server combining two tools from AWS. The CDK library that we are using to develop the infrastructure as code of our project, and the SAM CLI from AWS, which is a CLI meant for developing serverless application. To enable the invocation of your Lambda from the browser, you have to include an additional resource, which is a REST API. In this case, I'm including this just for local testing purposes, and you can use API gateway construct REST API to create a get resource, which is invoking our Lambda function. This is needed actually to test your Lambda from your browser. I created also an additional script that will synthesize your CDK template locally and will say the output in a file called template.yaml. This is important because the SAM CLI will look for this file, and then the script will invoke the SAM CLI to start a local API server, and I included additional let's say parameter to speed up the development of the project. So if we run this script start local environment, the server started. As you can see now, a new the terminal is displaying a URL you can invoke from your browser. Let's open the browser. This is the code that will be invoked. So the one that we just modified to include NumPy as an additional dependencies from our Lambda function. Okay, as you can see here, the response is correctly returning the NumPy version that we just installed. Let's quickly see also how we configure the TypeScript function. The configuration at CDK level is very similar. We are not including a Lambda layer in this case, but we are specifying a Node.js 16 as the runtime of our TypeScript Lambda function. Also in this case, for testing purposes, I'm including the REST API resource here. I also installed in the root package.json file TypeScript as a dev dependency, so you don't have to install it at global level. And just to simplify the way and to enable auto completion and remove some warning from the Visual Studio Code, I installed the node types from TypeScript. Since you know TypeScript is a transpiled code, here we will also enable with a new terminal the compilation of the watch of TypeScript file, and so whatever I write here will be automatically transpiled. Daniela, for example, I don't know if you notice the blink here because this is invoking. I will start again the local server. Also in this case, the URL is appearing here in the terminal. So I will open again terminal. Let's move this here. And hello world TypeScript world Daniele. Also in this case, let me see if how are you? This is automatically transpiling the code in JavaScript. The local server realizes that the JavaScript file source code of the Lambda function is changed. So he refreshed the auto reload actually the code in the server. And if I will now invoke here, the new modification will appear.